The universe is not evenly shaped. Across the darkness, matter gathers into clusters, filaments, and walls, threads of galaxies woven through a cosmic web so large that even the speed of light struggles to cross it. And yet, there are structures out there so immense, so sprawling across billions of light years, that they seem to defy the limits physics has written into reality. Tonight, we drift into that quiet frontier, where the largest known structures challenge the rules the universe should obey, a gentle paradox held in the silence of space. If this quiet journey brings you even a moment of wonder or rest, I am deeply grateful you're here. A gentle like, a soft tap on subscribe, it means more than you know, and it helps these peaceful explorations continue. Now we drift into the first chapter of this calm cosmic mystery. Part 1. The universe was never meant to be smooth. From the moment of the Big Bang, tiny ripples, just fractions of a degree, shaped where galaxies would someday form. These small imperfections grew into a sprawling cosmic web, a structure stretching hundreds of millions of light years in every direction. As we explore the largest of these forms, we discover that chaos and clumping were never mistakes. They were the blueprint for everything that followed. These ripples were not loud. They did not come with thunder or light. They were slight variations in density, gentle overdensities in the sea of primordial energy. Areas where matter, almost imperceptibly, gathered together instead of spreading evenly. Across the newborn universe, these tiny differences became destiny. Even as you breathe now, the echo of those first ripples continues to shape everything we know, our stars, our galaxies, even the place in the cosmos where you call home. Because the universe was never smooth. It was always meant to clump, gather, and form patterns far too grand for us to comprehend at first glance. When cosmologists speak of those early moments, they often refer to the cosmic microwave background, the faint afterglow of the Big Bang that fills the entire sky. It is a silent map of those original variations. If you could see it with perfect eyes, you would notice subtle temperature differences, just millionths of a degree. Yet those tiny differences would reveal where gravity was already beginning its quiet work. Gravity does not rush, it does not force. It waits and pulls slowly, patiently, sculpting structure from stillness. The universe expanded, cooled, and the densest regions began to collapse. Clouds of gas gathered, fragmenting into the first stars. When those early massive suns ignited, they illuminated the dark and unleashed the first elements forged in nuclear fire. Stars formed galaxies, galaxies formed clusters, and clusters assembled into something even larger, a cosmic design no one could see from the inside. Imagine zooming outward from Earth, lifting above the Milky Way, and then rising. Farther still, the spiral form of our galaxy shrinks, replaced by the patterns of the local group. Farther outward, the Virgo cluster emerges, and beyond that cluster, the view reveals filaments and threads where thousands of galaxies align like beads on invisible strings. The cosmic web, a universe-wide network of matter, drawn into patterns by gravity's unhurried hand. It looks like a map of neurons, like frost spreading across glass, like a lacework of galaxies embroidered into the dark. Between these filaments lie voids, enormous regions nearly empty, where matter never gathered enough to form stars. These voids are not errors in the design. They are the negative space needed for the structure to exist at all. The universe is as defined by its emptiness as by its brilliant arcs of light. What's most calming about this cosmic truth is how something so immense grew from fluctuations so small. It reminds us that transformation often begins in silence and that the smallest differences can create the greatest outcomes. Even scientists once believed the universe should become uniform given enough time. They imagined that inflation, the rapid expansion after the Big Bang, might stretch the universe so evenly that no direction or location would be special. But reality refused that simplicity. Instead, the universe maintained just enough imbalance for creativity. These early ripples were seeded by quantum fluctuations, microscopic uncertainties magnified across cosmic distance. The laws governing the smallest scales of nature help determine the largest scales of all. It is one of the most elegant connections in physics that the trembling of space-time smaller than an atom would eventually decide the structure of galaxies billions of light years apart. As the cosmic web continued to grow, gravity amplified its geometry. Dense regions became denser, clusters merged into superclusters, filaments thickened, and this process continues even now. Structures evolve, reshape, collide. Nothing in the universe has finished forming. The night sky may appear timeless, but everything you see is still unfolding. If you could fast forward the cosmos billions of years, these same structures would stretch farther apart, driven outward by dark energy. Filaments would thin, voids would widen. Galaxies that seem close enough to touch today will one day drift beyond the reach of even light. But tonight, in this quiet moment, the cosmic web remains connected, a masterpiece still in progress. One of the most comforting scientific revelations is the idea that nothing ever became orderly by accident. There was no mistake in the unevenness. The slight imperfections that shaped the early universe were essential. Without them, stars would never have formed, planets would remain unimagined, and the conditions for life would never arise. Chaos was not a flaw. It was the seed of beauty. Even now, when astronomers map these colossal structures, they find a kind of rhythm, patterns that repeat at different scales, like a fractal. Clusters resemble superclusters, which resemble the web as a whole. The universe seems to love geometry, but not a geometry of straight lines and perfect balance. Instead, it prefers a natural asymmetry, imperfect in the most perfect way. As you drift deeper into this journey, it can be soothing to remember that our existence is the result of those ancient fluctuations. The same physics that shaped the largest structures shaped you. Every atom in your body is a remnant of how the early universe arranged matter, not uniformly, but with purpose written in imbalance. You are here because the universe was curious, because it refused to smooth itself out, because gradients of energy and tiny seeds of noise refused to disappear. The largest walls, the most massive clusters, the gentle threads between galaxies, they are all consequences of that delicate defiance, a cosmos sculpted by contrast, not conformity. The universe did not seek stillness. It sought structure. It sought connection. And in that quiet pursuit, it created the possibility of stars forming worlds, worlds forming oceans, and oceans forming life capable of wondering how it all began. As we continue deeper into these structures, these immense shapes that stretch across billions of light years, we carry this awareness with us. Smoothness would have meant silence, but asymmetry meant creation. What began as a whisper became a web. What began as ripples became galaxies. What began as imperfection became everything we know. And so we move onward in this gentle story, into larger walls, greater clusters, and discoveries that test the limits of our understanding. Because if the first truth is that the universe was never meant to be smooth, then the next truth wonders just how big its structures are allowed to become. And as we keep exploring this cosmic web, one question quietly lingers in the darkness. If the universe could grow, structures this vast, what other impossibilities has it been quietly holding together all along? Part 2. The cosmic web, an invisible architecture. You can imagine it like a silent network, dark matter forming the scaffolding, galaxies hanging like dewdrops along gravity's threads. The cosmic web is the universe's hidden skeleton, shaping where matter can gather and where voids remain impossibly empty. It is vast, ancient, and still expanding. Its presence is felt long before it is seen. Dark matter does not glow, nor reflect, nor shimmer in any wavelength of light. It reveals itself only through influence, through the way galaxies orbit too fast to be held together by visible matter alone, through the bending of light around invisible curves. It is the gravity behind the glow, the quiet engineer of structure. Astronomers mapped its shape not by looking directly, but by tracing the way galaxies drift. They noticed that systems do not float in randomness. Instead, they move like schools of fish following unseen currents. Where those currents intersect, matter gathers into clusters. Where the currents diverge, the universe becomes quiet, a near-perfect silence of emptiness. The largest surveys of the sky, like the Sloan Digital Sky Survey, fill in these invisible blueprints. Millions of galaxies charted reveal threads stretching for hundreds of millions of light years. Each thread is a corridor of gravity. Each node is a city of stars. The cosmic web feels less like a construction and more like a living system, breathing, stretching, and evolving over time. A slow choreography set into motion more than 13 billion years ago. At its core lies dark matter, an unknown substance that outweighs every star and planet combined. It cannot be touched or held, yet without it, there would be no galaxies, no clusters, no beauty in the night. Dark matter is silent but powerful. Where it gathers, normal matter follows, gas cooling, stars igniting, planets forming, life emerging. In a way, the cosmic web is not just the architecture of galaxies, it is the framework of possibility. If you could float far above this structure, your vantage point would reveal something astonishing. Galaxies are not spread evenly like dust. They are arranged in patterns, long tendrils, arcs, and sheets of light. These filaments connect superclusters like bridges between islands. They stretch across space so vast that light itself takes hundreds of millions of years to travel from one bright bead to another. Between these structures lie cosmic voids, immense spherical regions where galaxies are rare and light is scarce. These voids are not empty by accident. They formed from regions where matter was sparse in the earliest universe. Gravity amplified the difference, draining them further as denser regions grew denser still. Each void is a monument to absence, a silence large enough to swallow thousands of Milky Ways without ever revealing itself. And yet, even here in emptiness, the cosmic web exerts its quiet influence. Some voids have faint bridges of dark matter running through them, subtle hints that the web reaches everywhere, even where galaxies do not. The most fascinating truth? This structure is not fixed. It is still forming, still stretching, still sculpting the fate of galaxies. Dark energy, the mysterious force accelerating the universe's expansion, pulls filaments outward like taffy, elongating their cosmic strands. At the same time, gravity within those filaments keeps pulling matter together, forming denser knots at the intersections. Clusters grow heavier, superclusters become more defined. The web tightens and thins in an ongoing cosmic competition between attraction and expansion. It is a balance that shapes everything. If we fast forward billions of years, the structure we see today will look different. Voids will widen, connections will stretch. Some filaments may break entirely, leaving galaxies isolated in the vastness. Future observers may not see the web at all, its patterns pulled apart by the accelerating expansion of space. But tonight, we are living in the perfect moment. A moment where the cosmic web is still visible, where structure remains connected, where light still travels the bridges between galaxies. There is something comforting in knowing that we exist at a time when the universe's design can still be mapped and understood. A time when our telescopes, like deep-time lanterns, can reveal the shape of everything. This web is one of the greatest achievements of modern cosmology. It tells us that the universe is not chaos, it is pattern. A pattern guided by laws so simple, yet so profound, that they scale from the smallest particles to the largest structures known. Gravity is one of those laws. Persistent, patient, always gathering. It does not demand attention. It simply waits for matter to arrive. Where it collects, galaxies are born, tiny sparks of order. Illuminating the darkness, stellar nurseries flare to life, lighting the filaments from within. When we observe the cosmic web through powerful telescopes, what we are really seeing are the brightest embers along its lines, galaxies marking the paths drawn by invisible hands. What we cannot see may be even more important. Dark matter forms more than 80% of all the mass in the universe. Without it, these structures would collapse or drift apart. It is a quiet guardian of balance, a hidden sculptor behind the galaxies we admire in the night sky. Supercomputers now simulate the web's evolution, recreating billions of years in moments. The results mirror what we observe, vast networks just like the real universe. This confirms that the web is not a cosmic accident. It is a natural outcome of the laws set at the beginning of time. As you rest here tonight, remember that everything around you follows this design. The Earth moves with the Milky Way with its cluster. The cluster with the great filaments that stretch into the dark. We are threads in this tapestry. We are part of the structure. We belong to the web. Even our future is tied to it. Galaxies migrate slowly along filaments, pulled into thicker regions. In billions of years, the Milky Way and Andromeda will collide, continuing the web's quiet flow toward denser nodes. New structures will rise where old ones merge. Even the collisions that reshape galaxies follow the pathways drawn long before stars existed. And through all of it, the web remains, an invisible map of destiny. The cosmic web shows us that order can emerge from randomness, that connection can form across unthinkable distance, and that even the darkest places are part of something vast. It reminds us that the universe is not empty. It is connected, bound together in patterns we are only beginning to trace. As we move deeper into these enormous formations, the walls, the superclusters, the great attractors, we carry with us this quiet truth. The universe grows along lines drawn by gravity. All things belong to a greater shape. The next time you gaze into the night sky, look past the stars. Imagine the threads that hold them in place. Imagine the structure that holds us all. And wonder, softly, how much more of this web we have yet to discover, and how far its connections truly reach. Part 3. The Sloan Great Wall, a quiet giant. In 2003, astronomers discovered something astonishing, a wall of galaxies stretching over 1 billion light-years long. It seemed to violate one of cosmology's guiding principles, that on the largest scales, the universe should look the same everywhere. But this wall didn't fit that rule. It stood out, immense and undeniable. They called it the Sloan Great Wall because its discovery emerged from the Sloan Digital Sky Survey, an ambitious effort to chart the deep sky with unprecedented clarity. What began as a mapping project evolved into a revelation. The universe had constructed a barrier of matter so tall and so wide that it dwarfed entire clusters, forming an elongated landscape of galaxies that seemed impossible to explain by standard models of cosmic formation. To appreciate its scale, imagine lining up 1 million Milky Ways side by side. That would just begin to trace its length. This structure spans more distance than light could travel in 1 billion years. It is not a single object, but a collective, hundreds of thousands of galaxies held loosely together by gravity and the unseen threads of dark matter. From far enough away, they appear as a single stroke across space, a cosmic sculpture etched into the universe's fabric. It forces us into a quiet pause, a moment of awe where we recognize that the universe has built something larger than theory predicted. The cosmological principle, the rule the Sloan Great Wall questions, says that at the very largest scales, matter should even out, that the universe should look essentially the same in every direction, smooth, uniform, no special places, no grand asymmetries. But this discovery suggested that cosmic architecture might remain structured at much larger scales than expected. A wall like this hints that the cosmic web has not smoothed out, not even after 13 billion years, and that gentle contradiction is where wonder begins. The galaxies forming this wall are not connected like bricks in a solid structure. They move independently, each with its own orbit, its own stars, its own history. But they are arranged along the same gravitational ridge, like lights tracing the length of a bridge that spans unimaginable darkness. If you could drift along the Sloan Great Wall, the journey would be silent and slow. You would pass clusters like shimmering cities separated by vast intergalactic countryside. The arcs between them would dim and brighten as distances widened and narrowed. Thousands of galaxies would glow beneath you like embers in an endless night. It is scale that gently overwhelms the mind. Scientists who first saw early data believed it must be a coincidence, a line of sight illusion. But additional surveys confirmed its presence. The wall was real, it was enormous, and it invited a deeper question. How could a structure this large have formed in the available time? Gravity can gather matter, but only so quickly. The universe has been expanding from the moment it began. For galaxies separated by such distances to end up aligned into a billion light-year structure, something must have guided the process. Dark matter is the first suspect. Its invisible filaments can link galaxies far beyond where starlight reaches. It creates the scaffolding that builds cosmic walls like this one. But even dark matter models struggle to account for such scale. The Sloan Great Wall forced cosmologists to wonder whether the early universe had already seeded these megastructures long before galaxies formed, or whether something else, something deeper, was at work. Some researchers suggested that the wall might not be a single structure, but a collection that merely appears connected from our perspective. A trick of cosmic alignment. But its shape, its continuity, and the movement of galaxies along its length all point to a shared gravitational narrative. Even if the wall is not continuous in a perfectly physical sense, it remains a part of the universe's grand tapestry. It tells us that the cosmos is capable of building forms that challenge expectations. When the Sloan Great Wall made headlines across astrophysics, it triggered a shift in scientific thought. What if the universe is not as uniform as the cosmological principle assumes? What if the largest scales are full of unique structures, great walls, enormous filaments, and quiet anomalies that stretch beyond what physics predicted? The discovery of even larger structures later, like the Hercules Corona Borealis Great Wall, did not diminish its significance. The Sloan Great Wall was the first crack in the assumption of uniformity. The first quiet reminder that our theories are approximations, and the universe holds the final say. As we consider it tonight, drifting peacefully in imagination through the cosmic web, another truth emerges. The universe loves to build more than emptiness. It loves pattern. It loves structure. It loves surprise. The Sloan Great Wall stands as a symbol of that creativity, an impossibly large boundary marking the edge of what early theories believed possible. If we had lived in a universe that was perfectly smooth, perfectly even, perfectly uninteresting, nothing of importance would exist. No galaxies, no stars, no planets, no life. Smoothness would have been silence. Instead, we live in a cosmos that clumps matter into wonders, and every great structure is a testament to those ancient, vital imperfections. When astronomers observe this wall today, they are not just charting dots on a map. They are reading a record of the universe's earliest motions, an echo of gravity sculpting the cosmos into shapes we can barely comprehend. All those galaxies, shimmering across billions of years, are the handwriting of creation. If you could stand at one end of the Sloan Great Wall and look outward, you would see galaxy clusters stretching past the horizon of visibility. The light from some would be so ancient that you would be looking back into a time before the Earth existed, before the sun ignited, before the Milky Way had its graceful spiral shape. The wall is as much a temporal structure as a spatial one, a bridge made of both distance and time. It is a reminder that even as we try to draw boundaries around what is possible in this universe, the cosmos continues to exceed them, quietly, calmly, without rush. As your mind rests in this scale, feeling the gentle hum of cosmic history, one thought rises. If a billion light-year wall is real, what else lies out there? What other giants stretch beyond the reach of our current maps? Because each discovery hints at a larger truth. The universe has not yet revealed its full size, and wonder will always expand faster than knowledge, so we continue forward, deeper into this tapestry of walls and voids, letting curiosity guide us. The Sloan Great Wall is not the end of the story. It is the beginning of a new question. What is the true limit of structure in a universe that refuses to remain small? Part 4. The Hercules Corona Borealis. Great Wall. Then came a discovery even stranger. A structure so massive, a reported 10 billion light-years across, that it stretched across a measurable fraction of the entire visible universe. If true, it would challenge the very idea of cosmic homogeneity, raising the quiet question, how could something that big have formed so early? This immense structure was not found by mapping nearby galaxies, but by studying distant explosions, the light of gamma-ray bursts flickering from a time when the universe was young. Scientists noticed something surprising. Too many of these bursts were grouped in the same region of the sky, as though they belonged to a single, incomprehensibly large formation. What they were seeing wasn't a single entity, but a vast alignment, a potential superstructure larger than anything physics currently explains. They named it the Hercules Corona Borealis Great Wall. Its name alone feels like a constellation whispered into myth, but its scale demands quiet awe. If we could drift above the universe and look down, this structure would wrap across a staggering tenth of all we can see. Not just a wall, a cosmic continent. To understand the shock of this discovery, consider the universe's fundamental assumption, the cosmological principle. It states that on the largest possible scales, matter should be uniformly spread, no direction too special, no region too dense. Beyond a few billion light years, structure should dissolve into randomness, but this wall did not dissolve. It clearly stands out, almost as if the universe traced a line there and everything listened. The implications ripple through cosmology. Gravity shouldn't have had enough time to shape something so vast. Cosmic expansion should have pulled such regions apart before they could connect. Inflationary models predict that giant walls should be extremely rare, maybe non-existent. Yet here it is, quietly defying the rulebook. It forces us to wonder whether the universe began with larger blueprints than expected, or if some cosmic influence, beyond what we understand, helped galaxies align into this colossus. And still, it remains invisible to the eye. We do not see a sharp boundary like the edges of a continent. Instead, we detect a gentle, improbable correlation across the heavens. Even now, scientists debate whether it is truly a single structure or several connected superclusters merely appearing unified across the cosmic web. But whether continuous or composed of pieces, its existence stretches the limits of what we believe possible. The most remarkable truth may be this: we do not yet know how the universe built this. As we imagine slowly gliding through its expanse, galaxies would pass like lanterns adrift in the void. Each cluster would carry countless suns, countless worlds, countless histories unfolding independently, yet bound together across billions of light years. Each galaxy seems small from this height, each cluster seems tiny, and yet together they redefine scale. In cosmic time, this wall formed earlier than expected. Looking at it is looking back through more than 10 billion years of history. Light from these galaxies began its journey when no planets had formed here, when the Milky Way was still assembling its spiral arms. The discovery suggests a profound possibility. The universe achieved complexity very quickly. It was already bold enough, structured enough, large enough to build giants in its youth. There is something haunting in that realization. We often think of evolution, stellar or biological, as a slow progression. But here, scale appears suddenly. Grand design emerges almost instantly. And this is not the only enormous structure we have found. Every few years, new surveys reveal more walls and filaments, each one stretching farther than the last, each one testing the edges of our understanding. As our telescopes reach deeper into the dark, the universe seems to whisper, "There is more than you imagined." The Hercules Corona Borealis Great Wall is not a mistake in measurement. Its pattern has been checked and rechecked. It persists across studies, across instruments, across analysis. Perhaps the greatest beauty in this discovery is the humility it demands. Cosmology does not panic when a rule is challenged. Instead, the universe becomes more interesting. Maybe our theories need adjusting. Maybe inflation behaved differently than our equations assume. Maybe dark matter organizes matter on scales we've only begun to comprehend. Maybe something entirely unknown influences structure beyond the cosmic horizon. As you relax into this thought, feel the calm difference between confusion and curiosity. Confusion resists, curiosity opens. Let the universe remain ahead of certainty. For now, the Hercules Corona Borealis Great Wall stands as a quiet monument to mystery, a shape too vast for current physics, too early in cosmic time, and too organized to easily ignore. If we could one day travel to its farthest edge, crossing billions of light years, drifting past clusters older than our sun, we would see stars and galaxies that have never known about Earth, never known about our questions, never known that they are part of something greater. Every dot of light is a story, every cluster a chapter, every structure a book written in gravity and time. And this is one of the longest stories the universe has ever told. We may never fully map its length, we may never walk its boundaries. But by recognizing its existence, we acknowledge a profound truth. The universe has been building beyond our expectations since the moment it began. This quiet giant reminds us that our theories are temporary, while wonder has no limit. And so we drift onward, deeper into scale, deeper into structure, deeper into the gentle questions that rise when we look into the dark. If this great wall is real, and all evidence suggests it is, then we must turn softly to the next question. What other impossibilities has the universe drawn into its sky, waiting calmly for us to discover? We carry that question into the next chapter of this cosmic journey. Part 5. Laniakea, our galactic home address. Our own Milky Way is not isolated. It sits inside an enormous supercluster called Laniakea, Hawaiian for immeasurable heavens. Thousands of galaxies move together like leaves in a slow galactic tide, all drawn toward a mysterious distant attractor. Home, on a universal map, is measured in flow. Laniakea is not a place with boundaries carved in light or matter. It is a region defined by motion, where every galaxy, including ours, drifts along invisible rivers of gravity. These currents guide their futures, directing them toward the same enormous destination. To understand where we live in the universe, we do not draw lines. We follow motion. The Milky Way is just one member of the local group, a family of galaxies that includes Andromeda and dozens of smaller companions. Together, they drift through space at about 600 kilometers per second, carried by gravitational currents. These streams do not move randomly. They flow downhill along the sloping terrain of gravity, falling toward deeper valleys carved into the cosmic landscape by mass. When astronomers looked closely at the directions of these flows, they realized that our local group was not moving alone. It was part of something far larger, a region containing around 100,000 galaxies, all traveling in a similar direction. This entire flow zone stretches across 520 million light years. That is Laniakea. Imagine standing at the center of this enormous structure, not physically, but in perspective. Around you, galaxies drift like small boats on a vast, dark ocean. None move straight outward. None drift randomly in the void. They all slide toward a deeper gravitational well. Something is calling them. That something, hidden behind a curtain of interstellar dust, is known as the Great Attractor. It is not an object that pulls with force like a magnet. It is simply a region where gravity has pooled more matter than the surrounding space, a gentle slope in the cosmic landscape. Galaxies follow that slope without choice, like leaves caught in a slow current. Laniakea was named in 2014 after scientists mapped these flows with remarkable precision. They used distance measurements, velocities, and the subtle distortions of galaxy shapes to trace the gravitational paths. Like following the winding pattern of rivers back to a source, they discovered that our Milky Way was part of a vast river network, all feeding the same gravitational basin. This discovery changed the way we think of address in the universe. Before, we located ourselves by structure: solar system Milky Way, local group Virgo cluster. But Laniakea adds an even deeper truth. Our address is not a point in space. It is a direction, a movement, a flow. Even now, the Milky Way travels toward the Great Attractor at over 1 million miles per hour. You do not feel this motion, but every star you see tonight is gliding through the dark at that speed. The Great Attractor itself remains partly hidden behind the dense plane of the Milky Way, an area astronomers call the zone of avoidance. Dust and gas obscure our view, like fog concealing a distant coastline. Yet gravity reveals what light cannot. Something massive lies there, tens of thousands of galaxies clustered into a structure, called the Norma Cluster, deep in the heart of Laniakea. And that, too, is not the final destination. The pull continues farther still toward an even greater mass beyond, the Shapley supercluster. Motion in the universe works like that. Larger structures always influence smaller ones. Gravity never stops at a border. It continues outward, always connected. You could trace this flow like a story of belonging. Earth circles the sun orbits the Milky Way drifts with the local group. The local group flows into Laniakea. Laniakea is drawn toward Shapley. We are nested in motion, always part of something larger. Laniakea's name reflects that scale. Immeasurable heavens, a reminder that what holds us is too large to fully comprehend. When astronomers charted its boundaries, they found that the universe becomes less connected beyond that region. Other superclusters move toward different attractors, following their own gravitational destinies. Laniakea is like one giant watershed in a universe filled with many regions defined by which direction matter falls. Where we live is not determined by walls, but by paths. There is a soft comfort in this perspective, because motion reveals connection, and connection reveals home. Even the most distant galaxy in Laniakea, hundreds of millions of light years away, shares a journey with us. We will never approach it. Our light may never reach it. But we are flowing together, part of the same grand migration. The cosmic web, which we explored earlier, forms the structure. Laniakea gives it meaning. It tells us which way the universe is carrying us. We often think of our place in space as stationary. We imagine Earth fixed beneath us, the stars peacefully pinned in a dome above. But motion is our true condition, constant, gentle, unstoppable. The universe breathes through its flows, and we drift quietly along. If you could close your eyes and feel the motion of our galaxy, you would sense the pull of unseen gravity, an ancient whisper guiding us through the dark. One day, very far from now, galaxies within Laniakea will draw closer to one another, merging slowly, forming larger and larger structures. Over trillions of years, as cosmic expansion pushes everything else away, Laniakea may become an island of light adrift in a vast sea of dark energy. All stars beyond our supercluster will fade beyond reach, leaving only this region as a visible universe to future civilizations. They will not know the cosmos as we do now. They will see only their island and nothing beyond it. We live in a time of connection, a time when the sky is still full of neighbors. The discovery of our supercluster teaches us something quiet and profound. Home is not a single galaxy. Home is a pattern of shared motion. Home is everything moving with us through the dark. As we continue, we will explore the deeper forces behind this journey, those hidden attractors and gravitational engines that shape the motion of entire superclusters. We will follow the flow until the universe reveals where it is leading us. But before we move on, take one last peaceful moment here. At the heart of the immeasurable heavens, where the Milky Way glides among thousands of sister galaxies, where gravity draws us onward toward a future we cannot yet see. This is Laniakea. This is our galactic home address, and it reminds us that even across 500 million light years, we are not alone in our motion. Part 6. The Great Attractor. A gravitational pull. Without a face. Somewhere in the dark between clusters, gravity flows toward a region we cannot fully see. Dust and stars block our view, yet everything around us drifts toward this hidden core. It is a destination without a visible source, a gentle tug written directly into the motion of space. We call it the Great Attractor because we do not truly understand what it is. We detect only its influence, not the shape of its presence. Looking out across the universe, galaxies should be carried almost entirely by the expansion of space, drifting apart like dots on an inflating balloon. Yet, when astronomers carefully measured the motions of galaxies around us, they found a clear deviation from that outward flow. Something massive was pulling us sideways through the cosmos. Our Milky Way speeds toward this point at nearly 2 million miles per hour. We feel nothing, yet everything is moving. This strange region lies in the direction of the constellations Norma and Centaurus. But between us and that part of the sky is our own galaxy. Thick lanes of dust and star fields we call the zone of avoidance. It is like trying to peer across an entire city through the densest fog imaginable. And so the Great Attractor remains partially hidden, a gravitational force without a revealed face. At first, scientists wondered whether we were being pulled by something familiar, just larger, perhaps a gigantic cluster of galaxies we had underestimated. But as observations improved, the mystery deepened. More matter lay there than expected, more mass than the visible galaxies could account for. Something huge shaped the cosmic currents, yet most of it was invisible. Dark matter is the simplest explanation, but the scale suggests something more complex, an entire architecture of clustered galaxies, superclusters, and filaments overlapping in that direction. The Great Attractor does not stand alone. It may be just one sinkhole in an even deeper gravitational valley. The region around it, known as the Norma cluster, is incredibly dense. Galaxies packed together there like stars in a jewel box, millions of suns bound into each small arc of sky. The very light we struggle to see hides the mass that moves us. But even that is not enough. As astronomers push their measurements farther, they realize that the flow continues past the Great Attractor. Our galaxy is not falling into that valley. It is sliding across its slope toward something. Greater still, the Shapley supercluster. It is like watching a river and discovering that the current does not end in the lake you first saw. It keeps rushing toward a far larger ocean. So the Great Attractor may not be a destination after all. It might be a milestone along a far deeper pull. And this is where the story becomes even more intriguing, because gravity does not act quickly. It sculpts with patience. For our entire cosmic history, the Milky Way has been drifting quietly in this direction, following the path etched by the cosmic web. Over billions of years, that pull has rearranged clusters and superclusters, an ongoing migration, changing the layout of the universe on the grandest scale. Imagine galaxies sliding slowly down invisible hills, gathering in the valleys. Imagine each star, each world, each civilization long extinct, all moving together without knowing why. This is the motion the Great Attractor embodies. Its pull is not violent or disruptive. It is subtle, constant, inevitable. When we try to visualize this, the scale feels impossible. Distances so vast that light takes hundreds of millions of years to cross them. Mass so great that even the expansion of the universe cannot drown its influence. Yet there is something peaceful in this motion. We are not drifting alone. Every galaxy in Laniakea shares this slow pilgrimage with us. Even though the zone of avoidance hides the core from our direct view, new instruments are beginning to lift the veil. Radio telescopes peer through dust. X-ray observatories detect hot gas between galaxies. Gradually, the structure is emerging, one quiet piece at a time. What we find is not a single object dominating space. It is a deep region where gravity has layered complexity. Clusters merging into superclusters, filaments feeding mass inward, dark matter anchoring it all. The Great Attractor is not a monolith. It is the combined will of thousands of galaxies bound together by gravity's slow intent. Teaches us a subtle truth. Movement reveals connection. Even when we cannot see the source, we can trace the direction. Astronomers call this motion peculiar velocity, the deviation from the pure expansion of space. It is peculiar not because it is strange, but because it is personal. It belongs to us. It tells the story of where we are being taken, and perhaps more quietly, where we have come from. Everything in space is tied to something larger, There are no isolated wanderers, only participants in a vast gravitational choreography. As you lie here tonight, your body at rest, your planet spinning, your star orbiting, it can feel as though motion and direction vanish in stillness. Yet the entire galaxy beneath you sails through the universe, guided by forces older than light. You are part of that journey. The Great Attractor reminds us that the universe's shape is not defined by what we can see, but by the unseen structures that guide motion. It reminds us that cosmic order emerges not from visibility, but from influence. In time, millions or billions of years from now, our galaxy will join others more closely. Distances will shrink. Collisions will reshape stars into new forms. The future of the local group is shaped by this quiet pull. We are being gathered, slowly, softly, patiently. The Great Attractor stands as a symbol of the universe's hidden organization, the ghost of gravity shaping the largest scales of existence without ever stepping into view. Its mystery is not frightening, it is humbling, a reminder that most of reality lies beyond the reach of direct observation. So we continue our calm journey through the cosmos, accepting that some destinations are known not by sight, but by motion. And as we leave this chapter, the question it offers is gentle, yet vast. If gravity can reach so far, what other invisible forces guide us across the universe, quietly shaping the paths we do not yet see? Our journey continues deeper into these structures, toward even greater gatherings of galaxies, toward the profound architecture of attraction that holds the cosmos together, and toward the next quiet mystery waiting in the dark. Part 7. The Shapley Concentration, where gravity overrules. Distance. Far beyond the Milky Way lies a colossal assembly of matter, so dense and massive that it redirects galaxies like rivers around a mountain. This region reshapes cosmic motion itself, bending the paths of entire clusters over hundreds of millions of years. We call it the Shapley Concentration, or the Shapley supercluster, and it represents one of the most massive known structures in the nearby observable universe. When astronomers map the flow of galaxies across hundreds of millions of light years, they see a clear trend. Clusters are not simply drifting outward with cosmic expansion, they are being drawn inward toward Shapley's gravitational basin. If the Great Attractor is a valley carved into spacetime, Shapley is a canyon, deeper, wider, more commanding. Our galaxy, the local group, and even our entire Laniakea supercluster are gently sliding in its direction, caught in the slow, steady pull of overwhelming mass. Shapley contains tens of thousands of galaxies, packed into enormous clusters linked by dark matter's invisible scaffolding. Each cluster alone has more mass than 1,000,000 billion suns. Together, they create a gravitational domain so influential that the motion of galaxies reveals its existence long before its shape becomes clear. Because light moves in straight lines, but gravity bends the paths of everything. The most striking thing is not its mass alone, but its distance. It lies 650 million light-years from us. Gravity should weaken across such distance, yet Shapley's influence reaches us here, in our quiet corner of space. That is how massive it is. If we could see this structure from above, we would witness a breathtaking flow, galaxies streaming inward along dark matter's threads, clusters rotating and merging, the cosmic web thickening around Shapley's heart, forming something like a gravitational capital of the local universe. And while the Great Attractor once seemed like the destination of our journey, Shapley is the deeper pull beyond it, the final slope, the true gravitational watershed shaping our motion. This realization only emerged in recent decades. As astronomers mapped deeper into the hidden southern sky, they found that the Great Attractor is only one part of a larger flow. The Great Attractor is a stepping stone. Shapley is the mountain. This idea is both grounding and humbling. Even great structures are guided by greater ones. The universe is never finished building upward. When you look into the night sky, the stars seem scattered randomly. But that is a matter of scale. Zoom out far enough, and pattern emerges. Clusters forming streams, streams feeding superclusters, superclusters bending their paths according to Shapley's gravity. A quiet cosmic choreography. Shapley's influence is so strong that it overrides the expansion of space itself, pulling matter inward faster than the universe pushes outward. That is not common. Most regions are expanding faster than gravity can keep up. But in Shapley, mass wins over distance. This alone makes Shapley a remarkable exception. Imagine drifting toward Shapley across the course of billions of years. Clusters would grow larger, galaxies would collide, merge, and ignite new waves of star formation. Each step inward would thicken the fabric of the cosmos. This inward motion is not rushed, it is gentle, a slow slide through space-time. Cosmologists use this motion to understand our deeper cosmic address. Our trajectory is curved, not straight. The local group flows toward the great attractor, and then continues further, gently bending toward Shapley. It is like rolling a marble that first dips into one small bowl, then continues into a deeper one, nearby. Gravity is not a force of command, it is a suggestion. Quiet, but unrelenting. Every star in our sky, every planet, every world that has ever existed in our galaxy is participating in this same migration. We move together as a community of galaxies, shaped by a gravitational landscape too vast to fully see. And yet, there is a subtle mystery within the Shapley story. For all its mass, for all its dominance, Shapley might still not be the final influence. Some models suggest that the cosmic flow continues beyond even Shapley, toward structures farther away, deeper still. But from where we stand in the cosmos, Shapley is the most massive gravitational anchor we have clearly measured. Its existence whispers that the structure of the universe is richer than the simple models once suggested. There are no simple boundaries, no obvious edges, only deeper and deeper wells of attraction. The more we zoom out, the larger the story becomes, and as science continues to refine measurements of motion and mass, these flows become clearer. We begin to trace the shape of the unseen. Gravity draws the map, light helps reveal it, and our curiosity fills in the space between. For a moment, imagine all of Laniakea, the thousands of galaxies that share our path, gathering like small streams converging into a river. That river runs toward the great attractor, and then cascades deeper, like water finding the lowest part of the world, flowing toward Shapley. This is the cosmic geography of home. There is something soothing about knowing that even at the largest scale, motion binds everything together. No galaxy drifts alone, no cluster remains untouched. The universe is not a static arrangement, it is a slow dance of mass and meaning. The Shapley concentration reminds us that structure exists beyond what we can see, beyond what we can measure easily, beyond what we can fully imagine. It reminds us that gravity is a storyteller, that motion is its quiet language, and we are part of the narrative. We may never reach Shapley. Cosmic expansion is carrying the universe apart too quickly now. But the direction of our drift will always connect us to it. We are shaped by distant giants. Our cosmic future influenced by mass we can barely observe. As you rest in this knowledge, feel the calm truth it carries. You belong to a journey larger than the scale of galaxies. Motion is your true state, gravity is your compass, and Shapley is the landmark that gives direction meaning. So we follow the flow forward, toward the next question. If structures this massive exist, how big can cosmic architecture truly become? What are the limits if the universe continues to gather matter across such vast scales? The next part of our quiet journey explores that very boundary, the limits of structure, where our theories begin to unravel and awe expands faster than explanation. Part 8. The limit of structure. Are we breaking physics according to our best hoary theories? There is a maximum scale where structure should dissolve into randomness. The universe shouldn't be able to organize matter beyond a certain size, yet it has. Some of these colossal structures seem too large to exist within the age the cosmos has had to form them. This rule the universe was expected to obey is called the cosmological principle. The idea that when you zoom out far enough, matter should appear evenly spread throughout space. No giant arcs, no vast walls, no preferred directions. Everything should blend into quiet uniformity. But discoveries like the Sloan Great Wall, and even more so, the Hercules Corona Borealis Great Wall, suggest that the cosmos may not have followed that script. Instead, it continued to build with ambition. The deeper we look, the stronger the quiet defiance becomes. Structures that stretch across a significant fraction of the observable universe challenge the boundaries of physics. They push against what our models say should be possible. If these structures are truly real, and evidence keeps growing that they are, then something about our understanding of the early universe is incomplete. To grasp the scale of this problem, imagine the timeline of cosmic growth. The Big Bang lays down tiny fluctuations. Gravity begins to amplify dense regions. Galaxies form in those regions. Clusters merge into superclusters. Superclusters gather into walls and filaments. But the key ingredient here is time. The universe has only had 13.8 billion years to build all of this. Gravity works slowly, especially over billions of light years. The expansion of space stretches everything apart. Structures should stop forming past a certain scale, yet they didn't. The question becomes gentle and unsettling. Did the universe grow faster and more efficiently than expected? Or are our expectations too small? Some scientists propose that these structures may not be truly connected. They might just appear aligned by coincidence, clusters that only seem like a single shape from our point of view. But the continuity of motion, the underlying dark matter scaffolding, and the repeating patterns argue otherwise. Others suggest that dark matter and dark energy may behave differently on extremely large scales than predicted. In our equations, they are consistent forces. In reality, they may have hidden complexity. And then, there are deeper ideas. What if space-time itself has subtle curves at the largest scales? What if the universe has topology, a shape or twist that encourages monumental structures? In that case, these giants might not be breaking physics at all. They may be revealing physics we have yet to write. As you settle into this thought, breathe with the rhythm of cosmic calm. Our confusion is a doorway. Wonder is what walks through it. Even the cosmological principle, a cornerstone of modern cosmology, is not sacred. It is a model, a simplification, a way to make sense of scale we can barely fathom. When the data changes, the principle must evolve. The universe is not obligated to match our assumptions. It only follows its own laws. Laws we are still learning to translate. The possibility that the cosmos may be more structured, more uneven, and more surprising than once believed is both unsettling and beautiful. It means there is more to discover. Let's follow the thread of scale further. If a structure is 10 billion light-years across, then the light from one end to the other takes nearly the entire history of the universe to travel. That means such structures would have needed to form extremely early, when the universe was too young to allow matter to gather on such a grand scale. The timing does not fit our equations. Gravity should not have had enough time to gather so much matter so far apart. So perhaps something else helped shape these giants. Primordial quantum fluctuations larger than expected. Enhanced dark matter clumping in the early universe. Variations in cosmic inflation that stretched space unevenly. A deeper underlying structure that seeded the web at enormous scales. These ideas sit at the edge of research. They are hypotheses floating in the silence, waiting for evidence. If we take a step back, we see a gentle irony. Every time we find something too big to exist, we call it a problem, when it is actually a discovery. Because discoveries force growth. They push understanding outward. They invite us to rewrite the map. The limit of structure becomes less like a wall and more like a horizon. This segment of our cosmic journey reminds us that the universe has never been small. It has always exceeded the boundaries of imagination. Every assumption about scale was made during a time of limited perspective. We stand now at the brink of a deeper vision. Surveys grow larger, telescopes see farther, simulations become more precise. The universe expands faster than belief. Understanding expands to keep up. If enormous, structures are truly real, and they likely are, then the cosmos may be revealing a deeper pattern, one that does not vanish with distance but persists across unimaginable scales. Perhaps the universe is fractal-like, patterns repeating again and again from galaxies to clusters to superclusters to walls to something even larger, waiting beyond our current horizon. If that is true, then we have not reached the limit of structure at all. We have only reached the limit of observation. As you drift deeper into rest, let this knowing hold you gently. Our map of the universe is unfinished. Our theories are stepping stones. Every structure larger than expected is a message. Keep looking, keep wondering, keep rewriting the rules. The universe is not broken. Physics is not failing. We are simply uncovering a cosmos more adventurous and ambitious than we once dreamed. The largest structures are not errors, they are invitations. And as we continue, we will follow those invitations into even darker and more mysterious territory, to the quiet regions where light rarely travels and emptiness becomes a shape of its own. Part 9. Light as a Witness, How the Deep Sky Remembers. When we see distant galaxies, we are not seeing them as they are, but as they were billions of years ago. Light becomes a time machine, showing structures frozen in their earliest forms. The largest walls are fossils of motion, snapshots from when the universe was young and bold enough to bend its own rules. Every photon that reaches your eyes tonight has traveled a distance so great that time itself is woven into its journey. The farther away a galaxy lies, the further back in time we look. The cosmos does not offer us the present. It reveals its memory layer by layer across distance. In this quiet truth lies a beautiful paradox. Space is also time. When we observe the Hercules Corona Borealis Great Wall, or the Sloan Great Wall, or any other colossal structure, we are not seeing a modern shape. We are studying their youth, their earliest formation, preserved in ancient light. By the time that light finally arrives, the universe has already changed. Galaxies have already traveled farther, collided, transformed. Stars have been born, lived, and died. Clusters have migrated along the cosmic web. But the light does not know this. It carries the past to our present. Astronomers call this look-back time, the silent record of how things once were. And through it, we uncover the deep history of structure formation. The universe keeps a visual archive, but it is not organized in books or scrolls. It is spread across the darkness, one page per photon. The night sky becomes a library. To read it, we must look across billions of light years, collecting faint signals from the earliest galaxies. Instruments like the James Webb Space Telescope and deep Earth-based surveys trace these ancient paths, mapping how matter arranged itself shortly after the Big Bang. And that is when we notice the impossibilities. Structures appear too large, too early. Connections form across distances where gravity should have remained quiet. Light brings the contradiction to us, calmly, faithfully, like a messenger who knows only truth. We are left with a gentle mystery. How could the universe build giants before it had the time? Light offers many clues. As galaxies move away due to cosmic expansion, their light is stretched into longer wavelengths, a shift toward the red end of the spectrum. This redshift acts like a timestamp. The higher the redshift, the further back in time we are seeing. Some structures detected through high redshift gamma ray bursts belong to a universe less than 20% of its current age. These clusters of bursts reveal massive formations where we never expected to find them. Light remembers their youth even if gravity has since moved them onward. This is what makes the sky so profound. Everything twinkles with history. Every galaxy is a window into a different era. And yet, light is not perfect. There is a horizon, the distance beyond which no light has ever had time to reach us. That is the observable universe's boundary, not the limit of existence, but the limit of memory. Beyond that edge, the cosmos remains unlit in our minds. Still, what we can see is astonishing. A single pit of darkness through a telescope, like the Hubble Ultra Deep Field, reveals tens of thousands of galaxies layered in time. The closer ones are bright and fully formed. The distant ones are dim and compact, infant galaxies burning with the first stars ever made. Light from those primitive stars has traveled over 13 billion years to find us. Think of the journey, a universe expanding around each photon, stretching its wavelength, slowing its energy, but never halting its devotion to the message it carries. Light is patient. It does not forget the story it set out to tell. It is through this patience that we know the early universe was far more structured than expected. We see alignment where randomness should reign. We see organization where chaos should dominate. We see great walls where smoothness was predicted. Light exposes the bold truth. The universe did not take long to become complex. It assembled its architecture quickly, guided by the smallest quantum fluctuations, sculpted by the quiet pull of gravity, illuminated by the first stars. The structures we study today through ancient photons are evidence of an ambitious cosmos, a cosmos that began constructing wonders before there was time to be modest. It can be overwhelming to consider that every image of space is a glimpse into the past. The Andromeda Galaxy shines as it was 2.5 million years ago, when early humans first began shaping tools from stone. The nearest major star systems shine from decades or centuries in the past, light delayed across mere slivers of cosmic scale. Your entire field of vision is a mosaic of different ages stitched smoothly into one view. If you were to wave your hand at the speed of light toward a distant galaxy, its inhabitants, if such observers exist, would see that gesture millions or billions of years from now. Your motion becomes part of the cosmic archive. Light turns existence into memory. There is something deeply peaceful in this. The universe remembers. It records without bias. It keeps every moment available for someone, somewhere, someday to witness. As our instruments improve, we peel back earlier epochs, watching stars ignite in young galaxies, nebulae forming the elements of future worlds, and clusters converging into the first large-scale structures. We are, in a sense, stargazing archaeologists. Light is our relic. The cosmos is our excavation. Time is our tool. These immense structures, the largest in the universe, reveal themselves through light that is floated across unimaginable distance. They exist not only in space, but in time. And as we trace their ancient outlines, we begin to understand that the universe once allowed itself greater ambition, and perhaps still does. When we look up, we are not seeing what is, we are seeing what was, and inferring what must be. Light asks us to accept a quiet duality. Everywhere we look is the past. Every discovery is a memory. Every wonder is already changed. Yet none of that diminishes the awe, because memory is enough to reshape understanding. As you rest beneath the stretch of stars, remember that the sky you see is history preserved with precision beyond language. Light is the universe's most faithful storyteller, and the deep sky keeps its secrets not by hiding, but by arriving slowly, gently, after journeys longer than our planet has known life. The cosmos does not rush to reveal itself. It gives us time to learn, time to reflect, time to wonder. And in the arriving glow of ancient photons, one soft realization emerges. If this is what we can see, what stories remain untold beyond the reach of light? As we continue this quiet journey deeper into the cosmic map, we follow those stories into regions defined not by brilliance, but by emptiness, where darkness itself becomes the next great shape to explore. Part 10. Cosmic Voids, where nothingness is a shape. Between these enormous walls lie regions more silent than imagination allows, immense pockets of near emptiness. They are not just gaps, they are part of the structure itself. Voids define shape through absence, giving the cosmos texture, depth, and contrast. If the cosmic web is the universe's skeleton, voids are the spaces between its ribs, the dark breath of the cosmos. These voids are not small. They are often hundreds of millions of light years across, sometimes more. Entire galaxies can fall into them and float alone, separated from others by unimaginable expanses. Some voids are so vast that the entire Milky Way could fit into them, tens of thousands of times and still leave room to drift. They are the loneliest places we know to exist, and yet they are essential. Without voids, walls could not rise. Without emptiness, structure could not form. Cosmic voids reveal a strange truth: nothingness has shape. At first glance, one might imagine the universe is crowded. Billions of galaxies, trillions of stars, planets beyond number. But on the largest scales, emptiness dominates. Galaxies cling to thin threads and meet at dense nodes. Everything else is quiet, vast regions where matter simply isn't. These voids formed because the early universe was not perfectly even. Regions that began slightly less dense became even emptier over time. Matter flowed away toward brighter, richer parts of the web. Voids expanded like bubbles in rising bread, growing larger as the universe aged. Gravity gathered where matter was plentiful. Expansion grew where matter was scarce. The rich became richer. The empty became emptier. This is the cosmic contrast from which beauty emerges. If you could drift into one of these voids, you would travel farther than the entire span of known civilization, longer than any future journey humanity might ever manage, before finding another galaxy. The night sky from a lone galaxy in the center of a void would be sparse, almost blank. Stars would appear fewer and faint. The cosmos would feel strangely hollow. It would be a universe with more silence than story. Yet even in voids, matter is not entirely absent. There may be a few faint dwarf galaxies, small, dim, clinging to existence. They are like candles in a cathedral of darkness. Some of these galaxies move differently than those near denser regions. Their paths are not guided by proximity, only by the gentle stretching of space itself. They drift outward, carried by dark energy, like dust pulled by a quiet breeze. If clusters and walls are the stage for cosmic drama, voids are the calm silence between acts. They are not mistakes in the universe's design. They are the reason the design has meaning. Astronomers discovered that voids are not simply empty spheres. They have complexity. Filaments that almost formed but never fully grew. Galaxies that might have joined clusters but remained isolated. Pockets within pockets, like fractal shadows. Each void is a story of what could have been. One of the most famous voids sits relatively near us, the local void, a neighboring region largely devoid of galaxies. Its gravitational absence is so great that it actually pushes the Milky Way outward, gently guiding our galaxy's motion away from emptiness toward denser regions of the cosmic web. Even nothingness can move us. This is one of the quiet marvels of cosmic dynamics. Gravity pulls, emptiness pushes. We are sculpted by both. The interplay of matter and void shapes the universe in slow, graceful tension. While walls form dramatic structures, the visible bones of the cosmos, voids widen the gaps, deepening the geometry. Together they form a pattern reminiscent of frost on glass, soap bubbles clustering, or neural pathways in a brain. The universe seems to repeat its favorite forms across different domains. Perhaps these similarities are not coincidences, but expressions of the same physical truths playing out in different arenas. Voids also serve as laboratories for understanding the universe's most mysterious force, dark energy. These regions expand at a faster pace than cosmic average, making them the purest expression of the universe's accelerating growth. They are the front lines of expansion. If expansion is the universe's breath, voids are where that breath is longest. When we look into these vast pockets of darkness, we find that the deepest questions live there. What is driving expansion faster than gravity can resist? Why does emptiness grow more quickly than fullness can hold? What rules govern the absence of matter? Voids are not the leftovers of creation. They are the environment in which creation unfolds. As you imagine floating through one, picture the immense dark corridor around you. Billions of years pass like gentle tides. A lone galaxy glimmers in unimaginable isolation, a reminder that existence persists even where it feels most improbable. There is serenity in this solitude. Perhaps that is why contemplating voids feels strangely calming. They embody a profound stillness, not lifeless, but resting. The universe is not filled with chaos. It is filled with balance. For every cluster bursting with newborn stars, there are voids where silence holds the narrative together. For every region where gravity binds tightly, there are expanses where space relaxes into openness. These opposites define each other. In your own life, there are walls, moments of density, noise, activity, connection. But there are also voids, quiet hours, empty spaces, pauses between breaths. Neither is complete without the other. The cosmos teaches through contrast. As we continue to map the universe, the voids will grow more significant. Future telescopes will peer deeper into the darkness, revealing threads too faint for today's instruments. The gaps will become clearer, and through them, so will the structure. Because form is revealed not only by what is present, but by what is absent. Cosmic voids remind us that the universe is a shape with boundaries and hollows, a sculpture of stars and silence working together. They tell us that emptiness is not a mistake. It is a feature, one that allows everything else to shine. So as we drift onward, deeper into the mysteries of scale and existence, we carry this understanding with us. Nothingness has structure. Silence has purpose. Emptiness shapes reality. And in that quiet architecture, the universe continues to grow, stretching into forms too vast for certainty, too subtle for quick answers, and too beautiful to ever fully understand. Our next step leads us to the most elusive form of cosmic construction, the expansion itself, where distance becomes a force, and the future of structure depends on how fast the universe breathes outward. Part 11. Expansion. When distance outruns gravity. Every second, space stretches relentlessly. Faraway galaxies are carried outward faster than their own light can return. The structures we see today are held in a delicate tug of war, gravity trying to bind them together, expansion trying to pull them apart, and one day, distance will win. Cosmic expansion is not just about objects drifting apart, it is space itself growing, a quiet swelling of the universe that has continued since the first moment of time. In the earliest seconds after the Big Bang, the universe expanded faster than the speed of light, an era called inflation. It smoothed the cosmos outward in every direction, setting the stage for galaxies to emerge from the small pockets of unevenness left behind. And though inflation ended long ago, expansion never stopped. It simply slowed. Then, billions of years later, it began, speeding up again. Something unknown is pushing space apart faster than gravity can pull it together. We call that force dark energy. Not because we understand it, but because we don't. Gravity binds, dark energy unbinds. This is the fundamental tension shaping the fate of the universe. Right now, the two forces are in balance. Just enough structure is formed to give the cosmos depth and complexity. But the balance is shifting. Dark energy grows more influential as space enlarges. Gravity weakens with distance. Eventually, dark energy will win. Not with violence, but with distance. As galaxies drift further apart, light from one galaxy will no longer reach another. Communication will fade, visibility will shrink. The universe will become a collection of islands, drifting away into unobservable solitude. Even today, there are galaxies so far away that their light will never reach us. They are receding faster than photons can return, not because they are moving through space, but because space is stretching between us. The cosmic horizon is a boundary defined by distance and time. Beyond it, the universe expands too quickly for light to bridge the gap. We are fortunate to live in a moment where structure can still be seen. Galaxies still cluster. Superclusters still influence each other. The cosmic web still shines with connection. But the future will look different. Even the largest structures, the great walls, the superclusters, the cosmic rivers of galaxies, are held together only because gravity has already locked them in place. They formed early enough to bind before dark energy gained dominance. Everything else will eventually slip away. In this way, expansion preserves history. The structures we see today are fossils of a more connected universe. Imagine two boats floating on a calm lake. They remain near each other for a while. But if the lake itself begins to stretch, if the water expands from underneath them, They drift apart without ever rowing. That is the universe. Galaxies are the boats. Space is the water. There is no center of expansion. Everything expands away from everything. Even right where you sit, space quietly stretches around you. Atoms are strong enough to hold together. Planets and stars defy expansion through gravity. But galaxies only remain unified because their mass outweighs the stretching of space within them. Between galaxies, though, expansion wins. As we look deeper into the universe, we aren't just seeing other places, we are seeing different eras of expansion. Distant galaxies appear younger, smaller, faster moving, because their light left when the universe was young and expanding differently. Cosmic history plays out in the sky. There is a peculiarity in how the largest structures exist at all. They formed in a narrow window, after inflation slowed, but before dark energy accelerated again. Had dark energy awakened sooner, structure would never have grown beyond tiny clusters. The universe would be a sparse field of lonely stars. Instead, matter had time to gather into walls, superclusters, and giants like Laniakea. We exist in a rare chapter of cosmic evolution, a middle moment between chaos and isolation. One day, even the nearest galaxies not bound to the Milky Way will disappear from view. Expansion will carry them too far away to see, too far away to reach. Their light will be stretched into invisibility. Future astronomers, billions of years from now, may look up and see only the remnants of the local group, a merged supergalaxy in an empty night. The cosmic expansion will erase evidence of the universe's structure. It will hide its own history. Only now, in this fleeting era, can we map the vast architecture of the cosmos. There is both melancholy and wonder in that truth. Expansion does not destroy. It simply distances. It reshapes the scale of relationships. Gravity holds nearby galaxies in place, but expansion stretches everything else like a tide that never recedes. This expansion is not chaotic. It follows precise rules. It is smooth, uniform, and deeply woven into the fabric of space-time. Einstein's equations allow this. They even predicted it. Yet, predictions do not soften the awe, because expansion presents a gentle reminder. Nothing in the universe stays close forever. Everything changes, everything drifts. Even galaxies separated by billions of light years feel the quiet separation grow. But expansion also made room for everything we know. For galaxies to form without instantly collapsing under their own weight, for stars to shine without overcrowding, for life to have space to evolve. The universe grows outward, so there is room for possibility. As you reflect on this scale, the vastness becomes less intimidating and more like a promise. The cosmos is not shrinking into darkness, it is creating space for the future, even if that future is quieter, more isolated, and more mysterious. The expansion of the expansion universe whispers a truth that is both cosmic and personal. Connections must be cherished while they exist. Moments of closeness are rare. Separation is part of growth. We live in a universe that is still unfolding. We are passengers in an expansion that will continue long after memory fades. The largest structures ever built by gravity are beginning their long goodbye. But tonight, while we can still see them, we honor the beauty of the distance between us and the wonder of a cosmos that stretches beyond imagination. The next part of our journey takes us to the very edge of the observable, where the horizon hides what lies beyond, and the limits of what we can know remind us how small our map still is. Part 12. The edge of what we can know. The observable universe is not a boundary of all that exists. It is simply the limit of what light has had time to reach us. Beyond that horizon, more structures may lie, larger walls, deeper voids, patterns far more immense than anything we've mapped so far. We call it the cosmic horizon, not because space ends there, but because our knowledge does. Light from beyond that distance has not had the 13.8 billion years required to cross the expanding gulf of space. The universe could stretch on for trillions of light years in every direction, and we may never know. We live inside our view, but the cosmos lives beyond it. The observable universe is like a bubble, one that expands every moment as ancient light, arrives from farther and farther away. Yet the space outside that bubble expands faster still, carrying distant galaxies beyond where their light could ever reach us. There is a quiet sadness in that idea. Most of the universe is destined to remain unseen. And yet, this limitation creates a profound sense of curiosity. Because at the boundary of what we can observe, we detect large-scale structures pressing against the edge of visibility, hints of something bigger. When astronomers measure temperature variations, in the cosmic microwave background, they find subtle alignments, patterns suggesting that the universe on scales larger than we can see is not entirely random. These observations point toward something beyond our boundary, influencing the shape of what lies within it. Cosmologists call this the cosmic flow problem, the motion of galaxies that seem to be streaming toward a direction beyond our observable limits. It's as if a gravitational pull exists outside the horizon, drawing matter inward from a place we cannot witness. Something out there, unseen, unlit, unreachable, may be shaping the universe we can see. This raises a gentle possibility. Perhaps the largest structures we've discovered, the walls and clusters that seem to defy our theories, are only fragments of something much greater, pieces of architecture stretching into the unobservable. Imagine the Sloan Great Wall, the Hercules Corona Borealis Great Wall, Laniakea, Shapley, not as finished forms, but as corners of a larger design. We are like explorers standing on a shoreline at night, mapping the coastline by lantern light, knowing the ocean continues endlessly into the dark. Even with today's most powerful telescopes, we see less than 5% of the universe. The remaining 95% is dark matter and dark energy, forces we feel more than understand. We detect their influence as distortions and accelerations, but the sources remain hidden. Still, the horizon is not a wall, it is a moving frontier. Every moment more light reaches us, new stories arrive. The universe is unveiling itself in real time. There is a gentle comfort in knowing our knowledge has room to grow. That discovery is not a finite pursuit. But if the universe expands forever, as current evidence suggests, then the horizon will always outrun us. Meaning, we will never see everything that exists. Some galaxies born today will forever remain outside our reach. Their light will never arrive, their stories forever silent. The edge of what we can know is defined by both time and the speed of light, but even this speed, the fastest in the universe, is not quick enough to defeat expansion. And yet, we observe enough to glimpse grand possibility. Larger structures may form beyond the horizon, far more immense than those we already struggle to explain. Cosmic voids may grow deeper and wider, shaping a universe more fractured than we imagined. New physics may govern the realms outside, rules that differ from those within our visible domain. The universe may curve or warp into dimensions we cannot perceive, giving structure a complexity beyond simple geometry. We are humbled by our location, midway between the infinitely large and the infinitely small. Light, our greatest messenger, is also our greatest limitation. But this limitation is not a failure. It is the nature of perspective. Because the universe does not hide. It simply waits for time to reveal what distance has concealed. As we look out, we are also looking back. As we reach for the future, we unveil the ancient. The horizon is a meeting place between what was and what could be. Just beyond our grasp, structures continue to form and evolve, unknown giants in the darkness. There is no reason to believe the natural architecture of the universe ends where our instruments stop. The cosmos has not been designed for our convenience. It is vast because that is its nature. It is mysterious because mystery is the starting point of meaning. We stand at the shoreline of comprehension. The ocean calls us forward. We answer by building new tools, charting new maps, imagining new explanations. The edge of what we can know is not a limit. It is a promise, one that says, there is always more to explore, always more wonder to uncover, always more universe, quietly waiting. As we drift to the next chapter of this cosmic journey, we carry with us this gentle thought. We are part of something immeasurable. Our perspective is small, but our curiosity is vast, and that curiosity will continue leading us outward toward the next unanswered question, toward structures we can't yet see, toward the farthest reaches of possibility. Because beyond the edge of what we can know, the universe continues and invites us to keep looking. Part 13. Fractals in the dark. Some scientists wonder if structure repeats endlessly, like a fractal, pattern nested inside pattern. From star clusters to galaxy clusters to superclusters, each layer resembles the last. It suggests that scale may be less of a barrier than we once believed. This idea is quietly radical. It asks us to imagine the universe not as a smooth expansion dotted with rare features, but as a cascade of repeating shapes, a self-similar architecture extending far beyond our current horizon of knowledge. When we zoom into an atom, we find empty space, held together by invisible forces. When we zoom into a solar system, we see planets orbiting a star across vast emptiness. When we zoom out to galaxies, we see stars circling a center, again with dark space between. Zoom out further, and galaxies cluster into long threads and nodes, still with emptiness dominating. The structure feels familiar, as though nature has chosen a single style and expressed it across every scale. A fractal universe doesn't just imply repetition, it implies a deep unity. The same rules shaping a spiral galaxy might echo in the shape of a hurricane. The branching of rivers echoes the filaments of galaxies. The pattern of neurons echoes the cosmic web. Perhaps these similarities are more than coincidence. Perhaps they are a clue. If the universe is fractal-like at the largest scales, then the so-called biggest structures may not be exceptional. They may simply be early glimpses of a much larger repeating pattern. The Hercules Corona Borealis Great Wall might be a single thread in a structure billions of times bigger than anything we can imagine today. In this view, the universe does not smooth out, it keeps organizing. Order persists across every level of magnification. This concept unsettles the cosmological principle, the assumption that on the largest scales, the universe must become uniform. But look at what we've already seen. Enormous walls of galaxies, voids deeper and bigger than expected, flows caused by attractors far beyond our local region, structures that challenge time and formation, limits uniformity feels less and less certain. Still, cosmologists debate the idea carefully. A fractal universe must obey gravity and expansion, forces that stretch and smooth structures over time. Yet, observations keep hinting that patterns remain persistent over enormous scales. Even the cosmic web resembles a living system, branching like roots, spreading like nerve cells. Its geometry is not random. It follows mathematical relationships that appear again and again in nature. If you could float above the universe, far enough to see billions of galaxies in a single frame, you would witness something remarkable. The map of matter has rhythm. Clusters meet at nodes, filaments stretch outward, and voids pool like basins between mountains. Each part influences the whole. The pattern continues no matter how far you zoom. This is the whisper of a fractal cosmos. The beauty of fractals lies in their paradox. They are infinite in detail, formed by simple rules. The universe, despite its scale, behaves elegantly. The same laws that sculpt atoms sculpt galaxies. Gravity simply changes the size of the canvas, and if the universe is fractal, then the idea of largest structure becomes temporary. There will always be something bigger, something farther, something more connected. The ceiling of scale dissolves. We become wanderers in a cosmos without an upper limit. There's a quiet humility in that possibility. Our discoveries, no matter how vast, remain just beginnings. Some physicists propose that fractal structure only persists to a certain scale, perhaps a few billion light years, before leveling into smoothness. Others argue that smoothness itself may be an illusion caused by our limited perspective, by the horizon beyond which we cannot see. We stand in a dimly lit room of a far larger structure, mistaking walls for edges. One day, improved instruments may reveal structures 10 times larger than the giants we already know. They may map filaments connecting superclusters across gaps we once assumed too wide to bridge. and each discovery will feel strangely familiar. It is comforting to think that nature repeats itself. Patterns are how we find understanding. Repetition is how we know where to look next. Even in mathematics, fractals emerge from simple equations looping endlessly. In the universe, perhaps a few fundamental laws, gravity, quantum uncertainty, expansion, combine to produce complexity at every level. Like a musical, theme repeated in new keys. Yet the fractal universe, if true, raises philosophical questions as well. If patterns repeat forever, where does meaning lie? Is the universe finding new expression or echoing itself endlessly? The answers do not lessen the wonder, they deepen it. To rest in the possibility of an infinite fractal cosmos is to accept that discovery is evergreen. No final theory, no ultimate scale, just layers upon layers of cosmic artistry. The night sky becomes not a window into a completed structure, but an unfolding canvas. Every photon we receive is a brushstroke of a pattern still revealing itself. Every survey expands the picture, and every surprise suggests that repetition continues beyond sight. The brain's neural web, its tangle of thought and memory, resembles the universe not by chance, but because systems governed by connection often choose similar forms. Perhaps consciousness itself is a fractal, and by looking outward at cosmic structure, we are witnessing the geometry of thought on a universal scale. The great walls of galaxies are like synaptic links, voids like moments of silence between ideas, gravity like the binding force of meaning. In exploring structure, we may be exploring the architecture of awareness. If so, the universe is not just vast, it is intelligent in design, even if that intelligence is not intentional. Nature loves patterns. It expresses beauty through repetition, and we, as thinking beings, evolved inside that pattern, shaped by the same rules that sculpt galaxies. As we move toward the next chapter of this journey, let this idea settle softly. Scale does not define complexity. Vastness does not erase connection, and the largest structures in the universe may simply be the next expression of a pattern that has always been here. We follow this pattern now toward the largest of all cosmic questions, the mystery of what happens when expansion pulls structure apart faster than it forms, where the universe is headed and what shape it will choose in the end. And with that, we drift onward into Part 14. Part 14. When patterns challenge theory, every new discovery forces our equations to evolve. If the universe is more uneven and more structured than expected, then ideas about the early cosmos, about inflation, dark matter, and the shape of space may need to be rewritten with quieter humility. Science begins with a model. The model grows into a rule. Then the universe quietly bends that rule, and we learn to listen again. For decades, cosmologists believed the universe must become smooth at the largest scales. That structure would fade into randomness. This assumption is elegant, predictable. It gives order to the cosmos. But the structures we've uncovered, walls billions of light years long, clusters tugging from hundreds of millions of light years away, have become gentle contradictions. They say, softly, the universe is more ambitious than you thought. This is not the universe being disobedient. It is our understanding arriving late to the truth. The cosmological principle, once held as a foundational axiom, now appears more like an approximation, a useful simplification, but not the whole story. The cosmos simply does not flatten into perfect uniformity, not within the limits we have been able to observe. And so, theories must adapt. Let us explore the quiet revolution happening beneath the surface of cosmology, where data challenges expectation and physics rewrites itself in response. Inflation under question. Inflation theory describes a moment after the Big Bang when the universe ballooned exponentially, smoothing out irregularities. It explains why space appears nearly uniform and why the cosmic microwave background is so even. But if inflation worked perfectly, how did these enormous structures form so quickly? How did matter clump into filaments billions of light years across? This forces physicists to revisit the earliest moments of time, moments where quantum fluctuations may have amplified larger than expected patterns. Perhaps inflation had imperfections. Perhaps the expansion stretched some early ripples into titanic structures we now observe as great walls. Perhaps the universe remembers more of its chaotic birth than we realized. Dark matter as architect. Dark matter, invisible and elusive, forms the scaffolding that galaxies cling to. It gathers into filaments and nodes, directing the construction of the cosmic web. But to create structures, this massive dark matter may need to behave differently than we expect. Maybe it interacts with itself. Maybe it clusters more efficiently. Maybe there are varieties of dark matter, some warm, some cold, each shaping cosmic growth in their own way. Each new discovery asks the same question. Is dark matter more complex than silence suggests? Geometry of the universe. We assume space is mostly flat, like a vast stretched sheet. But what if space-time bends? Subtly on enormous scales? A curved universe could enable gravitational connectivity across larger distances than expected, allowing structure to form in surprising ways. In that case, walls and filaments are not rule breakers. They are simply features of a larger cosmic shape. We may be explorers mapping a surface we do not yet understand, a structure where straight paths curve gently into unexpected destinations. The humility of revision. Every scientific era has believed it was close to the truth, and every era, without exception, has learned it was early in the story. We do not yet know whether the largest structures in the universe are extraordinary or simply normal at a scale we have barely begun to access. We do not yet know whether smoothness is the default or the illusion. The universe has always been comfortable with paradox. It does not mind surprising us. It does not apologize for complexity. Scientific progress is not the replacement of old ideas with new ones. It is the quieter process of ideas maturing, like stars evolving, galaxies rotating, structures merging. We are allowed to be wrong along the way. Being wrong is part of being early. The future of cosmology. New telescopes and surveys will push deeper into the dark sky. The Nancy Grace Roman Space Telescope will map vast regions of cosmic mass distribution. The Vera Rubin Observatory will track the motions of billions of galaxies. The Euclid mission will search for the fingerprints of dark energy. These efforts will reveal whether the largest structures are anomalies or the opening chapters of a new understanding. We may discover that gravity has hidden depths, inflation has unexpected creativity. The universe's shape is stranger than geometry suggests. Darkness carries more structure than light reveals. Each of these possibilities requires us to rewrite the story of the cosmos, not from scratch, but from a deeper perspective. Awe before explanation theory is how we try to make the universe understandable. Awe is how we acknowledge that understanding is incomplete. We are still at the very beginning of cosmic comprehension. 13.8 billion years have passed, yet our knowledge is newborn. The largest structures ever observed are teaching us, gently, firmly, that scale does not respect our expectations, that formation can happen faster than we imagined, that the universe always has more to say. The next revision of cosmology may feel like a revelation, or it may feel like a reminder. The universe is not built to match the limits of our imagination. It may keep repeating its patterns. It may keep inventing new ones, but either way, it refuses to become simple. A quiet lesson. As you breathe softly, eyes closed or half-focused, letting the stars drift in your thoughts, consider this. Our theories are temporary. Wonder is permanent. The universe does not exist to be solved. It exists to be experienced. Curiously, carefully, humbly, we will continue refining our maps. We will continue questioning our assumptions. We will continue learning from what the cosmos reveals at the edges. Patterns will challenge theory. Theory will adjust, and the cycle will continue. Beautifully, patiently. Because discovery is not the end of a journey. It is the beginning of another. And with that, we turn softly to the next question, not about what the universe has already built, but about what it will build next, in the expanding dark where tomorrow's structures are taking shape. Part 15. A universe too vast to finish. knowing even if we spent 10,000 lifetimes charting the cosmos, we would still be looking at only one corner of something immeasurable. The largest structures remind us that exploration will always exceed explanation. Wonder expands faster than understanding. There is a soft truth that emerges the longer we study the universe. Knowledge is not a destination. It is a horizon that moves as we approach, forever drifting outward, forever inviting us to follow. Every new survey, every deeper map, every unexpected discovery pushes the boundary of our comprehension farther from where we stand. Like stepping into a forest and realizing the trees continue past every imagined edge. Structures too large to form within known physics, voids too deep to feel real, patterns too familiar to be accidents, currents of galaxies flowing toward unseen mass beyond our horizon. We begin by thinking the universe is simple. We continue by learning that complexity is its nature. We end not with final answers, but with a deeper curiosity that refuses to sleep. Standing beneath the night sky, gazing across light years, you might feel a gentle humility. We are small, but we are aware. A rare combination. Awareness allows the universe to reflect upon itself. Through your eyes, through billions of eyes across billions of worlds, known or unknown, the cosmos becomes conscious of its own existence. That consciousness fuels exploration. Questions become compasses. Wonder becomes the engine. Yet the scale we navigate is overwhelming. Our galaxy is a single swirl in a sea of trillions. Each star holds the possibility of worlds beyond number. Each world could carry stories we will never hear. The distances between them are so vast that even communication becomes unlikely. Light itself moves too slowly to keep up. We explore as far as we can, and the universe replies with silence, leaving us to fill the quiet with imagination. But there is comfort in knowing that silence is not emptiness, it is potential. We do not fear the unknown here. We welcome it gently, like a friend approaching from a long distance. Think of all the generations who once looked at the Milky Way and believed it was everything. A perfect island of light surrounded by darkness. They were not wrong. They were simply early. And we, in turn, are early now. One day in the distant future, astronomers may look back at us and marvel at how little we knew, how quaint our cosmic map appears, how tiny our observable bubble looks compared to the realms they have charted. And yet, even then, wonder will not be finished, because discovery does not shrink mystery. It expands it. New answers multiply new questions. Knowledge reveals deeper layers of ignorance. The cosmos grows more astonishing with every step. What we know today is a single chapter. What we have yet to understand is the library. Even if humanity explores galaxies, even if we live long enough to travel the cosmic web, even if we map everything light has touched, the universe may extend infinitely beyond the visible. Scale may continue forever. Time may carve new structures long after we are gone. Beauty lies in the continuation. We are part of a story that has no ending. A story so vast, no single species could ever truly finish reading it. And that is where peace resides, in accepting that we are not here to complete the universe, only to witness our share of its unfolding. As we reflect on the giants we've encountered, the great walls, the superclusters, the cosmic flows, one understanding becomes clear. The universe did not evolve to be understood. It simply evolved. We are the ones who chose to wonder. That choice is what makes our existence extraordinary. Consider how improbable it is that life arose at all. Consider how unlikely the emergence of consciousness was. Consider how miraculous curiosity is, that the universe created a way to question itself. Even if we unravel every mystery of dark matter, even if we decode the essence of dark energy, even if we observe the fabric of space-time at its deepest levels, new mysteries will grow in the space left behind. Because mystery is not a flaw. It is the heart of being. We are not here to conquer knowledge. We are here to be companions to wonder, to walk beside it into the dark, to listen when the universe whispers something new. And there will always be something new. Stars will continue forming. Galaxies will dance and merge. Cosmic structures will stretch and reshape. The expansion of space will rearrange destiny itself. Long after our civilization has faded, the cosmos will continue its quiet construction on scales far beyond our imagination. That continuation does not diminish us. It gives our existence meaning. Because to witness, even briefly, a universe this vast is a gift of impossible scale. You're living in a cosmically rare moment, a time when galaxies are still connected, when the largest structures can still be seen, when the night sky still holds clues to the totality of existence, a time when wonder is still visible. Future beings may long for our view of the universe, may dream of knowing what we once knew before the cosmos drifted apart. So in this moment, with stars above you and galaxies flowing invisibly beyond sight, you are part of a chapter where questions abound and answers inspire more curiosity than closure. That is, the beauty of being early. We are explorers at the dawn of comprehension. The first species on this planet to know it sits within a supercluster, pulled by unseen gravity toward distant realms, embedded in structure vast enough to reshape theory. We are the universe waking up, and as we drift toward rest, let one feeling stay with you. You belong here. In a cosmos too large to finish knowing, you are not misplaced, you are not insignificant, you are a participant in wonder, a witness to scale, a moment of awareness in an ocean of time. The universe is too vast to complete, but it is not too vast to love, not too vast to contemplate, not too vast to cherish, one discovery at a time. And so, with quiet awe, we turn the final page of this journey, not to reach an ending, but to acknowledge that endings do not exist in a universe still unfolding. Here, at the edge of understanding, we rest in the knowing that there is more to know, more beauty, more depth, more silence, more revelation. A universe too vast to finish knowing is also a universe too beautiful to ever stop exploring. As we come to the end of this quiet journey through the vastest structures ever found, let yourself breathe slowly, gently, the way galaxies drift through space, unhurried and eternal. Tonight we traveled farther than light can easily reach. We crossed superclusters, followed the flow of gravity, stood at the edges of immense walls of galaxies, and drifted through voids where silence itself forms shape. We learned that the universe is not smooth, it is not small, it is not finished. It builds wonders that stretch beyond theory, beyond distance, beyond imagination. Structures stitched together by gravity and separated by empty oceans of space. Yet, even in all this scale, you are not separate from the story. You are here, inside the cosmic web, a conscious moment on a tiny world in a spiraling galaxy that is flowing with countless others across an immeasurable heaven. As you rest now, let the enormity of the universe become a comfort, not a question. You don't need to solve it. You only need to drift within it, the way gravity guides galaxies, the way curiosity guides the mind. Wherever you are carried by motion older than time, held within a structure still being written. If this journey brought you peace or sparked a quiet sense of awe, I'm deeply grateful you shared this time with me. Your gentle like, your soft tap on subscribe, and your kind presence here mean more than you know. For now, let the stars fade softly into a quiet sky. Let your breath fall into its natural rhythm. Let the universe hold your thoughts the way it holds every world, delicately, endlessly, in calm and silent wonder. Good night, traveler. May your dreams drift as far as the cosmos allows, and may awe be your constant companion in a universe too beautiful and too vast to ever finish knowing.